Alright guys, today we're going to continue our work with solving equations. We're going to start off by looking at equations that have square roots in them. We'll also review how to deal with exponents that are fractions, and we'll see that that actually has a relationship to roots. We'll simplify some expressions that have fraction exponents, and then finally we'll solve equations that have fraction exponents. So that's our overall view for the day. Let's go ahead and begin. Once again, I'm going to be doing the odd problems and leaving the even ones for you guys to do. The first thing you want to do is get the square root by itself. Okay, so the first thing I'll do is I'll get rid of that negative 10 there. And then what you're going to do is, to get rid of the square root, you're going to square both sides. Okay, so I'm going to square here, I'll square here. That gives me 36, and on the right side, these cancel, and I have a over 3. After that, you should be able to solve like normal. So just multiply both sides by 3 to cancel the denominator out there, and you've got your final answer. And I believe that would be 108 if I'm not mistaken. And there you go. So that's the basic idea of solving equations with square roots. Here's number 2, so I'll let you guys go ahead and handle that one. And we'll move on to number 3. This is another type of problem where there's a square root on both sides. Doesn't really change much. I don't need to get rid of any numbers that are outside the square root, obviously, but I will just begin by squaring both sides, and that cancels out the square root on both sides. And after that, you just solve like normal. These are a lot like the ones that we had yesterday, where you could have an extraneous solution. So you do want to check for extraneous solutions. And what that means is your answer, when you plug it in, it should not create a square root that has a negative underneath of the square root as a result. It doesn't mean your answer can't be negative. It just means that you can't have a negative after you plug it in. And we don't, so that's a good outcome there. So the answer is r equals 1. All right? Here's one for you guys to try like that. Let's move on to number 5. Now this one's different because we have a variable that's under the square root, and then we have a variable that's not. Okay? So let me show you how to handle these kinds of situations. Now there's nothing over here that I need to do to get the square root by itself. It's already by itself. And there's nothing I can do on this side to fix that situation either. So we're going to just start by squaring both sides. But what's different about this one is, while over here these cancel and I get the same thing, on the right side, to simplify this, that really means a minus 8 is being multiplied by itself. And you're going to FOIL that out. Now you can use the box method, or you can use the shortcut method that I shared with you guys in one of our earlier lessons, where you just square the first pair, you square the last pair, you multiply these two and double it for the middle number. Okay? I like shortcuts, so I'm going to go with the shortcut, but if you don't like the shortcut or remember it, feel free just to FOIL it out. After that, you're going to go ahead and solve like normal. Now I have a square root. I have a, let me back up actually. I have a squared term. So if you have a squared term, we need to put it in standard form. First, and that means we're going to move everything over to one side. so that it equals 0. Let's see, subtracting these I would get 28. And then from there you're going to factor and solve. So we have 0 equals, now if you want to factor this using the box method you can, but I'm just going to go ahead and put the answer here. That'd be a minus 4 and a minus 7 is what would work there. And you're going to set each one equal to 0 and solve. And once again, these could be my answers, but I might have an extraneous solution here. But I'm pretty sure that if I were to plug in 4 here, I'm going to end up with a positive, because this would give me negative 20 if I plugged in a 4. And if I add 36 to it, it becomes positive. Same thing with the 7. If I plug in 7, I get negative 35. And if I add 36 to that, I still get a positive. So these are both good answers to keep. So don't forget to check for those extraneous solutions. But there's one for you guys to try on number 6. Let's go ahead and check out number 7, new topic here. Just want you guys to be aware of what fraction exponents are. Anytime you have a number being raised to a fraction power, you can rewrite that as a root. I'll put an A there, where you're taking the 8th root and then you're squaring it. I'm not squaring it, you're raising it to the t power. So this number becomes like your root, and this becomes like your power. Okay, so that's what those are. So on this problem, we're going to have 3x being raised to the 3/2 power. So that would be a square root of 3x being cubed. Okay, I'm going to leave it like that. Sometimes you can simplify these things a little bit, but I'll be leaving it like that because I just want us to know how to transform it into the correct format at that point. All right. Now you got to beware of another thing. If I had this instead, do you guys notice the difference between this expression and this one? The one that we have has parentheses on it, right? But this one doesn't. When that happens, the power only applies to the x, so this one would be written like this. So that's a little something that you're going to want to keep in mind. Parentheses matter on these. So here's one for you guys. I'll let you guys handle it. Now we're going to do the same thing this time, but instead of rewriting it as a root, we're going to write it as a fraction power. Now, for a square root, this is a regular square root. When you have a regular square root, the root is a 2, and the power out here is a 1. So if I wanted to rewrite that as a fraction power, this would be p to the 1/2 power. Same thing with that one. I'll let you guys handle number 10. So let's go ahead and take that fact and what we've learned about square roots a little bit and simplify an expression like this now. All right, so the first thing that we're going to do is we're going to change it into root form. So that's going to be the cube root of 27p to the 6th squared. Right? This is my root, this is my power. They go here and here. All right. The next thing I'm going to do is I'm going to find the root. So what do I mean by that? Well, you want to factor this thing. So what times what makes 27? Well, that's 3 times 9, right? And 9 is 3 times 3 also. So 27 is 3 times 3 times 3. And we also have 6 p's in there. All right? And we're trying to find the cube root of that before we square root it. Now, a cube root, basically, you're looking for groups of 3. So any group of 3 you have, I've got a group of 3s, you could write that number outside of the root and then cross off the 3's. Same thing here with the p's. I've got a group of 3 p's, so I could take a p out and you multiply it to the outside, and that goes away. And I've got another group of 3, so I could take another p out and cross off that group. Now in this case, there's nothing left on the inside. And when that happens, that means you just get rid of the square root. It doesn't matter anymore. Okay? Sometimes you will have some things left inside, but that is the simplification of the root there. Now, at this point, I've got 3 with 2 p's, which is 3p squared, right? But let's not forget, we do have this square on the outside, and for that, we're going to apply the exponent. Okay, so I'm going to square the 3, and I'm also going to square the p squared. 3 squared is 9, and p squared to the second power is p to the fourth. You basically just multiply those powers together. Okay, and so the final answer is 9p to the fourth power. So start by changing it into root form, simplify your root, and then apply the exponent after that. All right, so there's one for you guys to practice, and we'll move on to number 13. So now we're moving into our last set for the day, which is solving equations that have fraction powers. Okay, so the main thing I want you guys to know about these types of problems is how to get rid of the fraction power. To get rid of the fraction power, you raise both sides to the reciprocal power. So for instance here, I'm going to raise this side to the 2/3 power, the reciprocal of 3 over 2. And whatever you do to one side, you do to the other. So I'm going to raise this side to the 2/3 power. The reason we do that is because basically you're going to be multiplying these together, and you get 6 over 6, which is 1. So you have x to the first power, which is just x. So basically what happens is these cancel each other out. You can think of it like that. And now I've got 64 to the 2/3. Now after that, you're going to want to simplify the 64 to the 2/3 using the method that we talked about in the last problems, which is we're going to change it into a radical first. You're going to find the third root of 64. 64 just so happens to be 2 times 2 times 2, 6 times. And for every group of 3, we could take a 2 out. So I could take 1 2 out, I can take another 2 out, and there's nothing left inside the root, so we can just get rid of the root. So now I've got 2 times 2 squared, which is 4 squared, which is 16. All right. So there's one for you guys to solve. See if you guys can solve number 14 using that strategy, and we'll move on to number 15. So for problems like this, you want to get rid of the outside numbers first. We've seen that a few times now, if you did the last lesson that we did. So I want to get rid of this 4 before I do anything else. It's not that 4 is not under the power of the 1/3, and so it's free to be moved out of the way, like so. Now I'm going to raise both sides to the reciprocal power. Now 3 over 1 is just 3, so these cancel, and 2 to the 3rd power is 8. So get rid of outside numbers if there are any, and then there's one for you to try here like that. Now you're going to have 2 outside numbers to get rid of. You're going to start by adding 4, and then you're going to divide the negative 4. So you have 2 outside numbers to get rid of on yours. All right, let's go ahead and take a look at number 17. Now in this case we have an extra number, but this time it's in parentheses, which means that it's under the influence of that fraction. So I can't move the 11 until I get rid of that fraction power first. So in this case then, we're actually going to raise both sides to the reciprocal power first. That way I can get rid of that fraction power, and now the 11 and the p are free from that. Now before I go any further, I'm going to go ahead and simplify this expression. I want to find 256 to the 3/4 power. All right, so first of all, I'm going to rewrite it as a 4th root of 256 to the 3rd power. Next, I'm going to break down my 256. All right, 256. What does that break down into? I'm going to have to show my work on that one. I don't know. I know 2 goes in there. 2 goes in there. 128. I can see where we're going with this. All right, so you're just going to keep breaking it down. We're going to end up with 8 2s as a result. Let's make sure I got that right. 1, 2, 3, 4, 5, 6, 7, 8. One too many 2s there. All right, so now we're looking for groups of 4 identical numbers. So for every group of 4, I could take a 2 out. And it just so happens there are 2 of them with no root left over. So now I've got 4 to the 3rd power, which is 64. So I'm going to replace the 256 to the 3/4 power with 64. So after you simplify the power there, you can go ahead and just solve like normal. And there you go. So the main step I want you guys to be aware of is if you have more than one thing inside the parentheses all being raised to a fraction power, you're going to get rid of the fraction power first in that case. All right? And number 18 will be like that. Now I do want to caution you guys on yours, you're going to be raising both sides to the -2 power. Okay? That's the reciprocal of -1/2. Now over here, these are going to cancel out. On this side, though, when you have a negative power, it's going to do 2 things. It's going to square everything. So you're going to have 1 squared over 5 squared. But it's also going to flip it, and that's because of the negative. Negative exponents cause it to flip. So basically, what you're going to end up there was 25 over 1, which is just 25. So do be aware of what we talked about before, which is negative exponents. They cause you to flip the fraction over as you're simplifying it. All right? Let's go ahead and take a look at number 19. Number 19 is just a combination of a variety of situations there. So first thing I'm going to do is I'm going to add 8 on both sides. I want to get rid of the outside numbers first. Now adding 8 to this is going to be a little bit of a problem. I'm going to need a common denominator there. So that's going to be a pretty big number if I add 8 to that, because if you think of this as 8 over 1, I need to get a denominator of 16. So I'm going to multiply the top and the bottom by 16. So for that, I'm going to need a calculator. So bear with me for a minute while I calculate that. Eight times 16 is 128. So if I add those together, I end up with -1 over 16. Next, I'm going to divide both sides by 2, just -2 here, because I want to, once again, I want to get rid of everything that's outside the parentheses that's not being affected by the power there. So I'm going to divide both sides by 2. Now, how do you divide -1/16 by 2? Well, just put a -2 in the bottom. That's the same thing as dividing it. Okay? As a result, we will get the following. Make some space for myself. On this side, these cancel, and I have 3r plus 52 to the -5/6. And on this side, the negatives cancel, and I'm left with 1 over 32. Okay? And at that point, it's going to be like the problem that we had last time. So I had to get rid of the outside numbers first, and I had some nasty fraction work to do in the process. So let's go ahead and complete this now. We're going to raise both sides to the reciprocal power of -6/5. So on this side, these cancel each other out, and I'm left with 3r plus 52. And on the right side, the negative, I'm going to change that into a +6/5, and as a result, that's going to flip my fraction over, so it's 32 over 1. But I don't really need the 1 on the bottom, so I'll just leave it as 32. And then we're going to need to simplify that. So that's the 5th root of 32 raised to the 6th power. Now, we're going to simplify our root, so I'll leave a blank there and I'll show my work here off to the side. 32, if you break it down, would be 5 2's being multiplied together. And it just so happens I'm looking for groups of 5, and I have a group of 5 2's, so I could take a 2 out, cross that off, the root's gone, and so now I'm left with 2 to the 6th power, which is 64. So now I've got 64. And then from there, I'm pretty sure you guys would have no problem solving it. We're just going to be subtracting the 52 and dividing by 3. So let's do it. And I end up with 4 as my final answer. All right, and then we'll go ahead and let you guys try one of those there. So go ahead and try number 20. One more type of example I wanted to go over with you guys here was this type of problem. You'll see what's different about it as we work our way through. So the first thing we're going to do is we're going to get rid of the outside number 4 by dividing both sides by 4. And then we're going to go ahead and raise both sides to the reciprocal power. And now I'm going to simplify this, and this is where the new part's going to come in here. Let me show you. We're going to rewrite that as a square root of 4 to the 3rd power. Now, when you're solving, radical expressions with even roots, you get a plus and minus answer, okay? Because there's really 2 square roots of 4, right? We know the square root of 4 is 2, right? But, so just take the square root like you normally would. You could break it down and take out the pairs, or you could just know, oh, the square root of 4 is 2. That doesn't matter. But what does matter is that since we have an even root, we're going to get a plus and a minus answer there. So it could be a 2, it could be a 4, but if you have an even root, just know that after you take the root, you get 2 answers, a positive and a negative. Positive 2 raised to the 3rd power is positive 8, and then negative 2 raised to the 3rd power is negative 8. So you get 2 answers, plus and minus 8. And therefore, to solve for x, we're actually going to need to write 2 equations. One where x minus 24 equals 8, and one where x minus 24 equals a negative 8, and you solve both. So you would get 2 answers for those kinds of problems. So 32 is one of my answers, and 16 would be my other one. Okay, and that's that. So we'll let you guys try one like that. This one, yours likewise, will have 2 answers, but I'll leave that to you. And that'll be it for today. So hopefully it was helpful, and we'll see you guys later.